Alright. The first shape that we're looking at is the kite. Okay, the first shape you're looking at is the kite. So it says use the grid and kite provided to explore the properties of a kite. Okay, so find the length of each diagonal, and then using a protractor, find the measure of each angle, including those created by the diagonals. Okay, we're not going to get out the protractor. Instead, we're just going to use trig. Okay, so once we figure out all the sides of our triangle, we'll use trig to figure out those angles. Okay, so remember that diagonals go from one angle to the opposite angle. Okay, so from angle B to angle D is a diagonal. And then from A to C. Okay, what is the distance of segment BD, or diagonal BD? 12 units. Okay, what is the distance of AC? What is it? 8 units. Okay, so are our diagonals congruent? No. Okay, so that's one property we know is not true. Okay, if we name this point of intersection, let's say P, what is the length of AP?
4.
What is the length of PC?
4.
4. Okay, what is the length of BP?
3.
3. And from P to D? 9. Okay, so do our diagonals bisect each other? No. However, one diagonal bisects one of them, right? So this diagonal is bisected, but not both. Okay. What kind of angles are formed in the middle? Right angles. So what property could you say? The diagonals are perpendicular. Okay, what is the length of AB? 5. How do you know it's 5? Ooh. It's a Pythagorean triple, or you could do Pythagorean theorem if you didn't know that triple. What about BC? 5. Okay, what about AD? You can just write it as a radical if you want.
Radical 97.
Radical 97. So you have 16 plus 81 is the square root of 97. And CD?
Radical 97.
Square root of 97. Okay? I want you guys to solve for, let's do this angle. So angle BAP. And angle DAC. Okay, so if I want to solve for BAC, how could I go about solving for that? Sine inverse of 3 over 5 equals x. So what is the angle of BAP? 36.87. Are you in degree mode?
Yes.
Okay, just making sure. Okay, now somebody tell me the the measure of CAD or PAD. What do you get?
66.04.
66.04. Okay, what do you think the measure of ACD is? 66.04. What about BCA? 36.87. Okay, so I want you to find out 2 more angles. It's going to get a little tight up here, so you're going to have to write it off to the side probably. But I want you to find ABP and CBP. So CBP and CBP. Is which one? So you have what? Sine inverse of 4/5. Okay, what do we get? 53.13. What about CBP? So are they the same? Okay. And then we have our last two angles. You have ADP and CDP. ADP and CDP, these bottom two. What is ADP? 26.57, do we agree?
I got 23.96.
What do we get?
23.96.
23.96?
23.96.
Okay. And what about CDP?
23.96.
Okay. So, what do you think some of the properties of a kite are, now that we've kind of figured everything out? Diagonals are perpendicular. One diagonal bisects the opposite angle. Okay, so this diagonal here, our vertical diagonal, bisects our top angle and our bottom angle. One diagonal forms two pair of congruent triangles, our vertical one, because this diagonal here doesn't form two congruent triangles, but one of them does. What else?
Angles are bisected.
Only one set of angles are bisected. What else? Said that one. One diagonal is bisected, so your vertical bisects your horizontal. What else? What about opposite? What about opposite angles? Are they? One pair of opposite angles are congruent, so these two angles are congruent. These two are not, but these two are. What else? What about the sides? So you have two sets of consecutive sides that are congruent. So these, this set of consecutive sides and this set of consecutive sides. Okay, what about parallel lines? There are no parallel lines, okay? So that was a lot of properties that I just threw at you, but I am going to write them out for you, okay? So number one, okay, there are two pairs of congruent consecutive sides. Two pairs of congruent consecutive sides. Two, your diagonals are perpendicular. 3. One set of opposite angles are congruent. Only one set bisected by a diagonal. Okay, so you have one set of opposite angles congruent, and then the other set is bisected. So you have one set that's congruent, the other set is bisected. 4. One diagonal is bisected. So you have one set of angles bisected, and then you have one diagonal that is bisected. And then the last one is there are no parallel lines. And so this is why this lesson comes after the quiz, so that you don't get mixed up between parallelograms. Okay, so turn to your pink sheet and find kites. Turn to your pink sheet and find kites. Alright. Are opposite sides parallel?
No.
No. Are opposite sides congruent?
No.
No. Are all sides congruent?
No.
No. Are consecutive sides congruent?
Yes.
Yes. You have two pairs of consecutive sides congruent. Are opposite angles congruent?
One pair.
One pair. Are opposite angles supplementary?
No.
No. Consecutive angles supplementary?
No.
No. Consecutive angles congruent? No. Diagonals congruent?
No.
No. Oh, I skipped one. All angles right angles?
No.
No. Diagonals perpendicular?
Yes.
Yes. Diagonals bisect each other?
One pair.
One is bisected. Diagonals bisect opposite angles? One does. And diagonals form two congruent triangles? One does. Your vertical diagonal creates two congruent triangles. Okay, so those are your properties of a kite. Okay, when you turn the page, we have trapezoids. Turn the page and you have trapezoids. Okay, use the grid and trapezoid to provided to discover the properties of a trapezoid. Find the length of each side. What is the length of BC? 12. No. 10. What is the length of AD? 14. Okay, how can we find the length of BA? Pythagorean theorem. So if you draw a right triangle, okay, you have a leg of 2 and a leg of 9. So just leaving it as a radical, what would be the length of BA?
85.
85. 81 plus 4. Okay, what about CD? So again, you have 9 and 2. So same thing. Okay. It says find the length of each side. Also find point E, which is the midpoint of AB, and point F, the midpoint of CD. Okay, so how do I find the midpoint of AB? Very good. X1 plus X2 divided by 2. So I have the point -5, 6, and -7, -3. So I have -5 plus -7 divided by 2. -3 plus 6 divided by 2. What is the midpoint of that? -6 what? -6 what? 1.5. So somewhere in here. And that is point E. Okay, and then I'm just going to go across and do the same thing for F. Okay, so what would be the distance of EF?
Yeah.
12. Okay. Bases of a trapezoid, A, B, C, D. Okay, so what is one of our bases of this trapezoid? AD. And what is the other one? BC. These need to be labeled as segments. Okay, so proper notation. They should have a bar across the top. They are segments. Okay, base angles of trapezoid A, B, C, D. What is the base angles? You have angle A and angle D. And what are the other base angles? Angle B and angle C. Okay, so that's just a little bit of review. Okay, properties of trapezoids. Okay, so if it is just a plain trapezoid, you don't know, maybe it's not drawn to scale or you don't have the measurements, okay, to know that it's an isosceles or not. So if it's just a trapezoid, you have sets of parallel sides. Your parallel sides are always your bases. Okay, and then you have a set of non-parallel sides. Called your legs. So you have a set of parallel sides called the bases, and a set of non-parallel sides called the legs. Okay, when it is told that you have an isosceles trapezoid, or you're able to prove it by there being two congruent legs, okay, there's a little bit more properties. Okay, the first one, legs are congruent. Okay, so if we go to our picture, we proved that CD is congruent to AB. 2, base angles are congruent. And you have 2 pairs. Okay, so I have A is congruent to D, and I have BC is congruent, sorry, not BC, angle B is congruent to angle C. So A and D go together, B and C go together. Okay, number 3, diagonals are congruent. And they bisect each other. And number 4, opposite angles are supplementary. Okay, if the opposite angles are supplementary, what about the consecutive angles? They're also supplementary because angle D is the same thing as angle A. So these have to be supplementary too. It's just these sets, so I guess these consecutive angles would not be supplementary, but these go. So one pair, or one base angle of each pair are supplementary. Okay, triangle mid-segment theorem. Triangle mid-segment theorem. Okay, definition is it's the mid-segment of a trapezoid is the average of the two bases. Okay, so the length of your mid-segment is the average of your two bases. Okay, so your mid-segment equals B1 plus B2 over 2. Okay, so if you look at our picture up here, 14 plus 10 is 24, divided by 2 is 12. Okay, so the mid-segment is 1/2 of your two bases added together. So 10 plus 14 is 24, divided by 2 is 12, and that's why EF is your mid-segment. Okay, questions on our properties? Okay, pink sheet then. Real quick, we all turn back to the picture. I made a mistake. On number 3, they don't bisect each other, but they produce isosceles trapezoids. So like these two are congruent and these two are congruent, but they do not bisect each other. That's my bad. So you have isosceles trapezoids on top and bottom, which makes sense because of your base angles being congruent. Isosceles triangles, sorry. I said trapezoids like 5 times. Isosceles triangles, sorry. Okay, so your diagonals do not bisect each other. I got ahead of myself. Okay, your pink sheet. Okay, to differentiate between isosceles and regular, remember for your regular, all you have are 2 parallel bases and 2 legs. Okay, consecutive angles are still supplementary for regular trapezoids, but all you have is one side of parallel bases. Okay, whereas isosceles, you have opposite sides are parallel. Okay, you have that one pair still. Opposite sides are congruent because of your legs. So that's one pair. If you want to write that, you can. These are your legs. These are your bases. Okay, opposite angles are supplementary. Consecutive angles are supplementary. We talked about the pairs. Okay, so it has to be a mix of one of each of your base angles. Diagonals are congruent for isosceles, and this is not true, I just lied to you. Okay, so that's all you should have filled out for trapezoid. Okay, so we're going to put everything into practice now. Okay, quadrilateral ABCD is a kite. It is telling you it is a kite. Okay, if the measure of ABC is 95 degrees, what would be the measure of ADC? 95 degrees. Why? Very good, because you know that we have one pair of opposite angles that are congruent. Okay, if BCE is 34 degrees, notice that BCE is not the same as BCD. Okay, a lot of us still struggle when naming our angles. BCE is not the same thing as BCD. If BCE is 34 degrees, what is the measure of EBC? So what is the measure of this angle? How can we figure that out? How do you know this is 90? Very good, because the diagonals are perpendicular. Very good. 180 minus 90 minus 34 equals 56 degrees. So the sum of a triangle into your angles has to be 180. Okay, if the length of AB is 16 feet, what is AD? How do you know that? Very good. Two pairs of consecutive sides congruent. Okay, and number 4, if the length of BD is 25 feet, what is ED? What is it? 12.5. 12.5, why? Why is ED 12.5? Very good. One diagonal is bisected. Okay, so this was a little easy check for understanding just of all the properties, okay, of a kite. Okay, so now we're going to do the same sort of idea with quadrilateral WXYZ, and it is an isosceles trapezoid. Okay, so it is telling you, Sophia, put it away. It is telling you that it is an isosceles trapezoid. Okay, if XWZ is 66 degrees, what is YZW? Why is YZW 66 degrees? Very good. Base angles are congruent. Okay, if WY is 10 inches, oops, that was bad. What would ZX be? 10 inches, why? Very good. Diagonals are congruent. Okay, if WX is 7 inches, what is ZY? Why? Okay, because it's an isosceles trapezoid, legs are congruent. Okay, determine the perimeter of a kite Okay, so we need to determine the perimeter of a kite. How do we figure out what x is? Pythagorean theorem. So you have 10 squared plus 12 squared equals x squared. 244 equals x squared. Go to the hundreds. 15.62. You'll have one of these, I think, on your skills check or your test, one of them. Okay, how do we figure out y? Very good. Pythagorean theorem. I don't know what, is it 576? 676? 28.64. Okay, so add up all four sides, and what do you get as the perimeter of your kite? 88.52 inches. Question. Okay. Number 9. Given the following trapezoid, determine the length of the longer base. If necessary, round to the nearest thousandth. Okay, so what do we have here? A mid-segment. And you know that this is a mid-segment how? How do you know that this is a mid-segment? Because it bisects each side. So you have congruent sides here and congruent sides here. So it's on the midpoint of each side. That is why it's a mid-segment. Okay, so your mid-segment is what? Right. And how do you find your mid-segment? Okay, so your two bases averaged. Okay, so how am I going to get rid of the 2? Multiply both sides by 2. So I have 240 equals 20x plus 20. So I have 220 equals 20x. So what does x equal? Okay, so how do we find the length of the longer base? Plug in 11 for x for DC. And what do you get? 154. Okay, you know that 120, your mid-segment is half, essentially, of your two bases. So if you wanted to just multiply this by 2 and set it equal to 8x minus 2 plus 12x plus 22, you're essentially doing the same thing, but you're just saving that first step. Okay, so you can do it either way. Okay, number 10, find the variables. What kind of trapezoid do we have? Isosceles, and you know it's an isosceles by your markings. Okay, so what would be angle B? 92 degrees, and then how would you figure out A? Why 180? Opposite angles are supplementary, yes. And so what would be the measure of A? 88. Easy peasy. Okay, 11, the perimeter of the kite is 66, and it should say solve for x somewhere, but that's alright. Okay, how am I going to solve for x? The perimeter is 66. How do I solve for x?
minus 3 times 2 plus x times 3 equals 66.
Because you have two of these pieces. Okay, so you could just add them all up or just multiply by 2. So you have 66 equals 4x minus 6 plus 2x. 66 equals 6x minus 6. 6x equals 72. So what does x equal? 12. Does everybody see why we set up that equation? Okay, so you could either multiply each of the pieces by 2, or you could have just added them all up. So 66 equals 2x minus 3 plus 2x minus 3 plus x, and then combined your like terms. It's the same thing. Okay, important note for number 12. When we made this problem, we kind of just threw a bunch of numbers and angles on a picture so they don't actually go. So what I mean by that is if you do trig, you're going to get a different answer than if you solve using Pythagorean theorem, because we just threw an angle on here. They didn't necessarily correspond with the side lengths. Okay, so we need to pick a method and stick with it. So do you guys just want to do Pythagorean theorem? Do you want to do trig? Okay, so only use Pythagorean theorem then. Don't try to go back and forth, otherwise you're going to get different answers on this. Okay? Alright, so what would be the measure of A? 90 degrees. Okay, so we know this is 90. What would be the measure of B? 8. Why 8? Very good. The sum of these three angles need to be 180 degrees. Okay, what would C be? What would C be?
78.
Why 78? But you only have one angle. This is 12. Remember that these angles are bisected. Okay, so C would be 78. And then what would be the measure of D? 25. Okay, the biggest takeaway from a problem like this is just recognizing that not all of your angles are bisected, okay? Only the top and bottom, I would say top and bottom, but they could rotate this and it easily be left and right. But only one of your diagonals, okay, bisects your angles. Okay, any questions? I think that was the last one, yeah. Any questions? Okay.